So microservices, you saw the Gartner hype cycle earlier a bit today. The microservices are at the peak of expectations. They're extremely popular. Everybody's talking about them. Not that many people using it, but I'm living proof, right? Everybody's talking about them. So there is a lot of pressure to adopt microservices, even if it's not necessarily the best choice for a given problem. But it's one of the top reasons, not the best reason, but one of the top reasons for using microservices. Another more important and fundamental one is freedom. So microservices sort of formalize this aspect of programming to an API, not to an implementation. Yes, we've been saying that in the OSGi world for quite some time, but finally it went mainstream. So the argument is if you're talking to an HTTP endpoint using JSON, it really doesn't matter what's behind there, right? It can be Java, it can be Scala, it can be Ruby, it can be anything else. You can write COBOL if you want to. You can open sockets, hey. So this kind of freedom is good for the development team. So they are no longer tied to a single application platform. So they can implement it in whatever they find more suitable. And if you're a large distributed organization, have a very diverse skill set, you will find it very useful to give individual development teams the ability to choose their platforms. On the other hand, if you're a small focused shop which does Ruby on Rails very well, you will not have such an incentive of well, just allowing the developers to choose whatever they want. And I would sort of contrast this with the NoSQL movement that started maybe 7 or 8 years ago. And what I really took away from NoSQL is not necessarily one single NoSQL implementation. Okay, MongoDB is fantastic, but it's not the essence of the NoSQL movement. I think that polyglot persistence is something very important that came out of the NoSQL movement. So before that time, you would have a single database, one single database product, whichever that was, and that was the persistence choice for your application. On the other hand, with polyglot persistence, you can now understand you can choose multiple persistence technologies for your product. So if you want to have a cache in Redis and use MySQL for your persistence, and then you have a key value store for some other things, that's totally fine. I think microservices sort of does the same thing. You can have the most suitable platform choices for your application without being tied to a single choice. Now, resilience. If this has been touched upon in the previous talks, if you're doing microservices, you have to think about what happens when a dependency goes away. Previously, you probably have just a database connection pool, right? So you had to be careful with sizing, timeouts, how do you validate connections, and so on and so forth. Now you need to do this for a lot more, in a lot more situations, many more situations. Right, so that forces your application to be a lot more reliable. You had these constraints before, just that they weren't so neatly expressed. Scaling. Scaling, although from a numbers point of view, it seems harder with microservices, it's actually a bit simpler. When you wanted to scale these monolithic applications, you had large components, right? You have the big application server, the big database. And then if you wanted to scale your database, you needed, surprise, another big server. Because that's what you do with databases, right? You don't put them on micro machines if they serve your whole monolith, if they service it. So instead, if we have this, this is probably too small for you in the back to read, but this is an e-commerce engine, and you have two microservice instances. One is order processing, one is catalog search. And they just have some load balancers in front of them. So if you find out that this catalog instance has just two instances and it's too small, you pick up you just bring up 3 more instances just for the catalog. If you would have had 20 more services, you can even imagine taking servers away from the ones that don't do a proper resource utilization and giving them to this instance. So from that point of view, scaling is simpler and allows you to better utilize your resources when you're doing microservices, because you can do a better isolation of which resources are being used by what service. Reusability, I think this has been very well touched upon before. You can get different teams with different implementations to reuse the same logic because it's business level functionality. Let's say you have a geolocation service which is central to your application. You can reuse that when calculating shipping costs in microservice A, when trying to do customer support in module B, and so on and so forth. So reusability is really done better at the business level of microservices. Faster deployment, if you did the other things right. So if your microservices are very well isolated from each other, and they're fast to restart, then you can just quickly redeploy on each of those instances. And because other instances tolerate such kinds of minor downtimes, then you can easily deploy them and not have to take care of global downtime. There's even a deployment pattern, the green-blue deployment, which says just create new instances, put them in the load balancer, and destroy the old instances. You don't have to care. Now, what's more interesting to me is a sort of organizational advantage to using microservices. So many people do microservices for technical reasons, which I've outlined before. Another reason, which is pretty big to me, is doing more rapid releases. So I think no one would be happy to release once a year or once every 6 months or once every 2 months. It's slow. You need to go faster and it's faster. And what I usually see in the industry is teams doing some sort of iterative process like Scrum, which has releases every 2 weeks, 3 weeks, 4 weeks. And every 3 weeks, they do sort of such a big bang, but a smaller bang, and they go into production. So you can see such an example schedule here. 1 week release, 2 weeks pause. But then you get to the question, OK, how do we get these to be faster? How do you do more rapid releases? It's hard to get from 2 weeks down to 2 days. That's a pretty tough proposition for a big team. So what do? You split the deliverables as well. So each microservices is independently versioned and deployed. It has its own life cycle. And some teams, you will even find out that some teams will actually deploy every 3 weeks, like the big deliverable, but other teams are faster. And they had to wait 3 weeks because other parts of the team were slow. So in this ideal, I admit, example, you can have deployments each week instead of every 3 weeks. So yeah, it's not very visible, but actually we have this catalog team that releases every 3 weeks, and they were the ones holding back, quote unquote, the release. So that's one of the organizational advantages of microservices. But of course, not all is well. I managed not to reuse the poop slide, which is fine. But there are also some people which are a bit disenchanted with microservices. They're probably doing something wrong. I'm not sure what. But they're doing something wrong. And yes, I will repeat that point. If your product is not that hot as a monolith, it will be not that hot as microservices. But let's get to a bit more serious stuff. This is a list of fallacies of distributed computing that was coined like 30 years ago. It's still quite relevant today. Distributed computing is still interesting, still hard. I think last week we had the largest distributed denial of service attack in history, more on the number of tens of millions of IPs. The Internet of Things turned upside down, let's say. So yeah, the fact that we do distributed computing is a challenge that we sort of move away when doing monoliths. I don't remember my JVM dropping a method call ever. So yeah, that's something we need to live with when doing microservices. I want to focus on 2 of these fallacies. So one is that bandwidth is infinite and latency is 0. And microservices, so abstractly represented here, is this sort of cluster of microservices. Microservices tend to be very chatty, very verbose. Method calls are typically not an issue when running in process. When running out of process, you get to consume bandwidth. And if you have hubs of functionality that are called, that are central to your application, and they are invoked by many other microservices, you will get to have network spikes, and you will saturate the network. Of course, there are workarounds this, right? You can add local caches, which alleviate the problem. You can even move data around, delocalize. So it's the for web.o, we learned to denormalize databases, right? Now we delocalize databases. We just move data away and don't worry about it being stale. So there are ways around it, but these are trade-offs. Microservices do become harder to manage. Security. Yes, this is an actual hacker in action, ski gloves and all, and the mask. But the fallacy that I wanted to talk about is that the network is secure. The network is anything but secure. So when deploying microservices, you need to consider security a lot. So there are two things. One is authentication. How do you deal with the authentication story? Does every microservice go to a central point, ask for, validate the user credentials? What is the protocol that you do authentication and also authorization with? There are multiple technologies being passed around. You can do basic authentication. You can do OAuth. You can do client certificates. You can do JSON Web Tokens. There are many, many approaches, and we haven't yet matured enough to reach consensus on what would be the best for a certain solution, for a certain situation. Sorry. So that's still an open-ended question, whereas you don't need to have these problems typically in a monolith. Another is securing the transport. So ideally, your services would be running on a secure network. Whether it's an isolated network, which has one set of challenges, or whether it's mandating that everything uses encryption, so SSL, which is another set of challenges by itself. Now, imagine you're doing this to be more agile, right? And you have now you have a new microservices deployment process, which includes a 2-day waiting time to get the new SSL certificate. That's nothing but not agile. Or you have to deploy your own code certificate infrastructure, which takes time and effort. So again, something which speaks in favor of a monolith. Operations overhead. Now, in a monolith, you typically have a simpler technology stack. You maybe have an application server, such as Tomcat, a relational database, and some NoSQL database. So in here, it's a simple setup of Tomcat, MySQL, and Redis, duplicated for failover. Your ops team will learn how to manage them, how to provision them, and call it a day. But when going to microservices and giving your teams the freedom to choose whatever they want, they will choose whatever they want, right? So they will start bringing in new exotic technologies. And you may say that Docker helps. Yes, indeed, Docker helps. It's a great help. But it only tells part of the story. Docker doesn't help monitoring the health, the health of those instances. You will need to set up centralized logging, Docker registries, performance monitoring. And these are things which don't happen out of the blue, and they're not solved yet. So these are things which, again, your operations team will have to deal with. Again, not with the monolith. Code reuse. But yeah, I just said that's part of the advantages for microservices, didn't I? Well, it's also a disadvantage. Microservices sort of have this backing principle that the team who owns the microservices is fully responsible, right? But if you have teams that have multiple different microservices, different teams, the same platform, they will start implementing some basic functionality, not business-wise, but code-wise. They will have shared functionality. At that point, if you start sharing code between teams, the teams will not be in full control of the microservices, which sort of goes against one of the base principles. So that's a trade-off that you will have to decide whether you want to make or not. Code duplication versus ownership. That, again, you did not have in a monolith. This is completely unreadable. OK, has everyone seen Monty Python? OK, so most of you are familiar with Monty Python, the Holy Grail, where King Arthur comes to the Black Knight, and the Black Knight challenges a fight, and King Arthur starts chopping off hands and legs, but the Black Knight says, "It's nothing but a flesh wound. Come back and fight me, you coward." Now, this is sort of like an application which is sort of available. It says status 200 OK, but the microservices powering it are down. So the Black Knight is barely standing on one leg. Search is down, ordering is down, catalog is down, but some microservices are still sort of up, so the website is considered as being available. Now, the idea behind this is that when you have a monolith, it's either up or down. It's pretty hard to be sort of available, but with microservices, defining availability is a bit harder. Service discovery, I think we had some conversation about Zookeeper in the previous talk. So once you have all of these microservices, you need to know about them dynamically, not by some property list on an NFS server, but you need to allow them to register and the availability to be queried using a sort of a central registry. And of course, you can't allow it to become a single point of failure. So again, more fun. There are solutions like Zookeeper and etcd and whatever. But again, something you need to put into place for microservices. And ideally for production, for staging, and for testing. So troubleshooting. Again, Christian mentioned that you don't debug microservices. How do you do that? It's all easy when you have logging for a central service. When you have it for 200 microservice instances, it's really hard. You probably have to have a central log place where you aggregate all your logs, and then you make sense of them. You either sort them by timestamp and make sure the clocks are synchronized, which is an easy problem, right? Synchronizing clocks against across machines. And maybe even have some sort of identifier, that a request identifier or user identifier, which is present on all the microservices logs, so that you can make sense of them in the end. OK, I think I bashed on microservices enough. It's time to talk about microservices and microservices, or the different kind of microservices. Now, the question here is, what kind of microservices do you need? There's these microservices on the left, on your left, which are very similar and neatly organized, right? And those are the microservices where you say, we do microservices for organizational agility, but the platform runtime is going to be the same, or mostly the same. And you can say, we're a Java shop, we're going to do microservices with Java and OSGi. And that's the end of it. Or you can say we're a special snowflake. We have teams across 3 continents, across all time zones. We have people brought in from acquisitions who we were a Node.js shop, but those guys do Java very well. We're not going to force them to use Ruby. So microservices will give us the opportunity to let each one do the best they know and the best they can. So the question is, what are you trying to solve with microservices besides, being cool? What do you try to, allow the developers to express themselves better with technology? Then, OK, you go what I call unbounded microservices, so no rules, except this is what you have to deliver to the other microservices or to the other consumers. Or you go to bounded microservices, which say, this is a standard definition of a microservice, whether it's a Spring Boot, Drop Wizard, or OSGi, or something else. And I think the last question is very important, and it was pointed out in the earlier talks. Are you comfortable with partially embracing microservices? So you don't have to jump into the microservices ocean at 5 degrees Celsius and just take a fight to your architecture. You can start embracing microservices partially and see how that works for your organization. You can always go back if you do a modular monolith OSGi. Now, the middle ground. The middle ground is an API gateway. We've had this concept discussed a bit in the opening keynote today. So a gateway can bring a lot of value to this sort of heterogeneous environment that IoT has, but also to a bit of a small degree that microservices have. So there are many cross-cutting concerns when doing microservices that are well addressed in a central place. So I mentioned authentication and authorization earlier. Now, that gateway can serve as an entry point for authentication authorization so that each service doesn't have to reinvent the wheel, talk to the same central identity provider, for instance. It's a very good place for gathering key performance indicators, since it handles all the traffic that goes on in your microservices environment. Now, I think there was a question after the previous talk about what happens when something goes down in a microservices environment. How does it impact your availability and the performance of your system? And that's what patterns like a circuit breaker are about. So a circuit breaker, well, it wasn't invented in computers. It was invented in electronics or electrics, to be more precise. Is that when the capacity of a circuit is going to be too small for a power surge, it simply cuts off communication, right? That's the same pattern that we use when doing distributed services. If a service doesn't respond, just interrupt all communications immediately, and then periodically see if it's up. Or worse than a system being down is a system being slow, because that can kill the performance of the whole system. So if a system is slow rather than being down, you stop communicating with it and give it a chance from time to time to see if it has recovered. So all of this functionality, again, can be built into your API gateway. And there's a problem we know well of versioning. What do you do when you have a consumer that relies on an old version and you do breaking changes? Usually you say, tough luck, you need to adapt. Sometimes that isn't feasible. Sometimes a microservice that consumes microservice A consuming microservice B isn't able to adapt in time. So what do you do? Well, you can place the burden on a microservice that provides the service and say, we're going to serve 2 versions at the same time to accommodate the old users until they have the time. That's good, but sort of makes microservices bloated, which is not really the point, right? The point is to be small and agile and all that. Then the API gateway can take on that role. So rather than doing it on the provider side, you do it in the middle. You provide an adapter, which gives the consumers time to adopt. Now, those are the big things that I see happening in an API gateway. And it must be, of course, it's nice to be lightweight because you're going to deploy it a lot. It should be stateless because you want to scale out. The last thing you need is a gateway in the middle of your microservices architecture, which requires state. You can't scale it out, slow restarts, and it has to be extensible because potentially it should evolve along your microservices and the understanding that you have of your microservices architecture. Yes, that microservices gateway happens to be built on Apache Sling, and I want to tell you just a few words about Apache Sling. So unsurprisingly, it's an Apache project. It's almost 10 years old. I will not spend a lot of time on this. It's Java-based, since it's done with OSGi. It has increasing size of code, increasing contributions. And I happened to refresh an Apache status page and took a screenshot in the day where we had the most commits of all Apache projects. So I like to show that off. But OK, what does it actually do for us? So I say it's content-oriented and RESTful, which I will touch up on in the next slides. But it being content-oriented and RESTful means that it's a very good fit to being placed in the middle between a consumer and other microservices. It's lightweight. It has a small footprint on disk, by OSGi, and it's very easy to deploy. We also have this concept of fat jars. You just execute the jar and it starts. Now, what do I mean by content-oriented and RESTful? We, by default, have a hierarchical resource-based view of the world. We don't think in relational or database terms. We don't think in terms of NoSQL on columns or anything else. No, things are hierarchical. Everything is a tree. And resources, which are entities, whatever you want to call them, are placed in that tree. So in here, in a way to thin and no contrasting, not enough contrasting font is the root of the repository. Then you have a child/content, content blog hello world. And these are just properties in the repository, and properties have this path which uniquely identifies them in the repository, and properties. We have a rich persistence model, but we should not spend too much time on it. Now, how does Sling fit into this API gateway concept? Well, we have the entry point over here, which is authentication authorization. So the first thing that Sling does is authenticates the user. And it can optionally authorize it. So the microservices may have their own authorization data as well. But Sling can also do that for you as a sort of a pre-flight check. OK, the trivial cases where we know that the user is not allowed to access a certain path, do we really want to go all the way to the microservice and back to find out that he doesn't have the privileges? No. So we can do authentication and authorization in here. And then we have various resources, customers, inventory orders, which are mapped to different microservices. Now, Sling has this concept of resource providers. So by default, we have our resource provider, which is able to serve the whole repository. And that's based on something called JCR, a Java API for content repositories. But we can also plug in whatever we want. If we want to plug in persistence backed on Mongo, we can easily do that. We want to serve based on a file system, we do that. It's an OSGi extension point. So we can plug in microservices transparently into an Apache Sling. And being all of them being managed by Apache Sling, we can do logging, KPIs, circuit breaking precisely before the requests leave Apache Sling. And then they go to these various microservices, and the response is fed back into Apache Sling and then to the user. Demo time. But let me tell you first quickly about the demo. So it's a very simple application. In front, it's a web application. I will not be showing that. Then in here, it's a microservices gateway running Apache Sling. Has a couple of proxies. One list goes to a microservices which handles articles, and one goes to a spam checking gateway. Authentication, again, Apache Sling delegates authentication to our content repository, to Oak, which can optionally use an external identity provider, and then encodes the authentication authorization data using JSON Web Tokens and sends it to each microservice. This is a representation of JSON Web Tokens. I'm not going to spend too much time on it. The important part is that you have a payload, and you can encode any claims in it, who this user is, the roles, is an administrator or not. OK, so quickly going to the actual demo. Is this, I hope, visible enough? Now, the actual proxying code is quite simple. If I go to I have a Sling HTTP server request, which is able to uniquely identify a resource. It knows that because we map it to an URL, and in Sling, once you know the URL, you know the resource. And then we get the value of that proxied URL. So we know which microservice we're talking to. Then this is a simple pass-through of the request parameters. And in here is the interesting part. In here we use JSON Web Tokens. We add an authentication header, and we also set a request ID, which makes it easy to identify requests in going to various microservices. So to quickly go through the demo, so port 8080 is the gateway. Now, I wanted to show rather the articles. And I probably forgot to restart. Right, that was the second part of the demo where the authentication didn't work. Anyway, right, so I just proxied the articles from the gateway behind. If I look a little bit here, I can see that it has a 200 code, so it's a successful answer, but only because I passed in the credentials. Right, if that doesn't happen, I get a 403, and it doesn't come from the gateway. It comes right from the backend application. So I get a 403 here. But on the other hand, and these JSON web tokens are based on a shared secret. So if I change the shared secret on one side and I restart, the same thing that even with admin credentials, the same thing will happen. So I get back a 403 error. Something interesting here also to note is that we wrap our executions to web services using something called Hystrix. To keep it short, is sort of a circuit breaker library from Netflix. These guys do lots of microservices, and this allows us to gather lots of executions related to microservices. I just listed a few: execution time, number of requests. Now, since I think out of time, I want to wrap it up quickly. Apache Sling does lots of things. From a feature point of view, it's not even developed to be an API gateway, but it just happens to be because of the abstractions that back it. Microservices useful, but you need to understand that. I think even the previous two sessions said the same things. So I'll skip to an API gateway. Can bring a lot of value if you're doing microservices, especially if you're starting out. And try Apache Sling today. I try to focus on that a bit. So some resources if you're interested in finding out more about the technologies that I used to build this demo. And maybe we'll have time for a couple of questions, one or two if there are any.